today we're going to be talking about similar polygons. So first of all, let's review what is a polygon. So a polygon is a figure, a closed figure, that's made up of straight line segments for sides. And some of the ones we've looked at so far are triangles and quadrilaterals and pentagons and hexagons. And we just reviewed back in chapter 6 several of the names of the other polygons. So those are all polygons. Now when we're looking at similar polygons, the word here, similar, is going to mean that these are the same shape. So in other words, I couldn't have a triangle be similar to a hexagon. That wouldn't work. But not necessarily the same size. Remember that if they are same size and same shape, then they are congruent. And we're going to talk about every set of congruent polygons is also similar, okay, because they're going to meet the criteria here. But not every set of similar polygons will be congruent, okay, and that's because in order to be similar, they do not have to be the same size, and most of them will not be the same size, okay, and that's really important. And the way that that works is we might have a triangle ABC here whose dimensions are double that of triangle DEF. Okay, so I might have 10 and 8 and 6 for my sides here, and my sides on this one might be 5 and 4 and 3. Okay, so definitely a possibility here. All right, now we're going to talk about how we would write out a similarity statement. So remember when we wrote out congruency statements, that was when it had the little equal sign here. Not going to have that this time. It's just going to have the little wavy line. When we're talking about a similarity statement, we need to be able to match up our corresponding angles and our corresponding sides, same way that we did with the congruent ones. And the easiest way is going to be to look at the corresponding angles. Okay, so for example, here we have angle A and angle D are both marked with one tick mark. And the interesting thing about similar shapes is that their angles will all match up with a corresponding angle. They will all be congruent to one angle on the other shape, or else they are not similar. Okay, so if I write A down in the first position here, so this is the first position, then I need to write down its corresponding angle, angle D, in the first position on the second triangle's name. Okay, then B, angle B here has 2 tick marks, and angle E has 2 tick marks. So they both get to go into the second position of their respective triangle name. And angle C and angle F both have 3 tick marks. And so they both go into the third position. Now remember, if we were dealing with a quadrilateral, there would be 4 positions and you wouldn't have the little triangle in front. It would just be quadrilateral, A, B, C, D, E, or I guess A, B, C, D, sorry, is similar to, and you'd use the second name. And so that works for any polygon. So remember, some of those might end up with quite a few letters in their name, and the order of all of them matters, right? That's going to be really important. We're also able to look then at the the similarity statement. And once we've done that, once we've written it out, or if they give it to us, we are then able to identify some congruent line segments. So, I'm sorry, not congruent, some similar line segments. And when I say similar, it means they're going to be proportional. So if you remember those ratios and proportions we talked about in 7.1, those are going to come in handy here in just a minute. We're going to look at those. So for example, AB, which was 10, is going to be proportional to DE, which is 5. And BC, which is 8, is going to be proportional to EF, which is 4. And then you always have the first and the last letter, and those make up the third side, and those will also be proportional. There's just not an easy way to label that on here. Okay, so now we want to talk about scale factor. So scale factor is going to use these numbers that we've just identified, these sides, and we're going to identify whether the polygon is getting larger or smaller, whether the first one is larger or smaller than the second one. So we have triangle ABC here, and we're just going to choose to compare these first numbers we've identified. So from ABC, we're going to choose that side that was 10. That's the longest side on that one. And we're going to compare it to the longest side on triangle DEF, which is 5. Okay? And we put the 10 on top and the 5 on bottom because triangle ABC is listed first and DEF is listed second. Okay? Another way you could tell which one goes first or which one goes second is if they give you the similarity statement. So if they were written in this order in the problem, you would know this triangle is first, and you would know this triangle is second. Okay, and that's going to be really, really important as we go through this. And here's why it's important. So when we reduce this, this is going to give us our scale factor. And so 10 divided by 5 is 2. So this number here is what we call our scale factor. That is what would you multiply the second one by to get back to the first one. So if I was taking triangle DEF, I should be able to multiply each of the side measurements by 2, my scale factor, and that should give me the dimensions of my first triangle, which is 10. It also tells me that triangle ABC is 2 times as large as my second triangle, DEF. Okay, now let's look at why order matters. And I'm going to erase some of this extra writing. Okay, so I got rid of a lot of that extra drawing that was making us a little confusing. So when we look at this, the order is going to matter. So which one is first and which one is second is really important. For example, if I had chosen to put these backwards, okay, so if I had said that it was 5 to 10, then my scale factor would be 1/2. I would be saying that the first one was smaller, okay? In other words, that the first one is half the size of the second one instead of the first one being twice the size of the second one. So keep in mind, a whole number is going to mean that the first one is larger than the second one. A fractional number, whether it's 1/2 or something else, is going to mean that the first one is smaller than the second polygon, okay? And this goes no matter which kind of polygon we're dealing with. Another thing that is true, or should be true, if you have 2 similar polygons, is that it doesn't actually matter which side we picked as long as we are comparing corresponding parts. So remember we said we had A, B, and C here, and we have D, E, and F over here, okay, as our angles. And so we were comparing 10 and 5, and that's between the angle with 1 tick mark and the angle with 2 tick marks. Notice that's the same thing over here, 1 tick mark on D, 2 tick marks on E. Okay, that's really important. If we were going to compare a corresponding side, okay, that wasn't one of those, one way to find that would be to look at your number of tick marks on those angles. So I could say, you know, B has 2 tick marks and C has 3 tick marks, and so 8 is between them. So I could do 8 over E has 2 tick marks, F has 3 tick marks, and so that would be 4 is the side between them, and I could compare those. And you'll notice I got 2 again, right? So first we compared 10 over 5, and we got 2. And then we compared 8 over 4, and we got 2. And if we compare the last 2 sides, okay, between the 3 tick marks and the 1 tick mark, that's 6. The 3 tick marks and the 1 tick mark, and that's 3, so 6 over 3. And guess what? We get 2 again. So you should get the same scale factor every time if they are similar polygons. Okay? If they're not similar polygons, then one of those three will have, or more, will have different ratios. They will reduce to a different number, and they will not be similar polygons then. So you can test that out. Another way to decide which measurements of the sides go in or could be compared would be to do the largest side from triangle ABC over the largest side from DEF. And so we'd get 10 over 5 for that one, right, which we did. And then to do the smallest two sides, okay, which would be 6 over 3, which we did. And then the two that are left over are the middleiest. I know, not a word, but the two sides at the middle measurement, and that would be your third one. So that's another way you can compare those. Okay. So we will look at some more examples of this in class tomorrow, and I really appreciate you watching. Thank you, and have a lovely afternoon.